In this video, we are going to be taking another variation of valid palindrome. Now, this is another variation, and this variation is a bit tricky. The way it's tricky is basically the problem statement says that you're given a string, right? And you can delete at most one character to make that string as palindrome, right? So all you need to return, you don't need to return the character. All you need to return, if you remove at most one character, can you make that string as palindrome or not? Okay, so let's take a look at an example. So ABA is still going to be true in this case because it is a true palindrome. Now, if you take a look at ABCA, basically just putting C in place, you're going to notice that this is going to be a valid palindrome as well because you can remove C and still be able to make that string ABA as palindrome. Okay, so hope that makes sense. Like, if you delete that character, like, that then you can make it as a valid palindrome. So that is a very interesting question. So I would actually ask you to take a quick stab at it. Now, once again, keep in mind the last solution that we did for valid palindrome because that is still going to be valid. It's just we are going to tweak that a little bit to basically keep track of something, right? So that's the hint. And go ahead and pause the video and see if you can actually come up with a, possible algorithm and then resume back to see what we have got as a solution for you. Okay, so pause the video now. All right, so hope that went well. We are going to take a look at what kind of solution we came up with. So here is the solution that we have. Is basically what we're going to do is that hint was basically keeping a flag when you first encounter the out of order element. So keeping a count when you encounter that C. Okay, and when you encounter that C, you say like that hey flag has been turned on. That means I already encountered. I skip that particular element and then continue the loop forward. Okay, so with that hint, let's first take a look at the example because this was rather tricky. So I actually thought it would be helpful to take a look at the example first. So we have the string ABCA divided into ABCA character array. Now I is 0 and J is 3, right? I is 0, first pointer, and J is 3, 0, 1, 2, 3. Okay, so initially when we start the loop, our I is going to point to A and J is also going to point to A, right? So we're going to say A is equal to A, true, we continue forward. Next iteration, we increment I to point to B and decrement J to point to C. Now B is not equal to C, right? So we use that flag. So we said like, removed already, which we initially set to false. Now we actually set it to true. Okay. And then we actually check this condition. So we first check, can we increment I, right? And get the solution. So if we increment I first, so if we increment I to from 1 to 2, we go in the loop again, right? So let's take a look at the code now. So we go okay, so let's keep this thought like right here, and let's go into code because we're gonna need help from the code. So what we have here is we still take like a string input from the user. Now because we want to keep track of that flag and we don't want to create a universal variable to keep the track of the flag, we can actually create an internal function that is going to supply flag value along with everything else. So we're gonna supply the array, the start pointer, the end pointer, and if the item is removed already, the Boolean flag. Okay, this is also going to return Boolean, and the return result of this function is going to be returned eventually to the user. So what we do is that we say our I is initialized to start pointer and j is initialized to end pointer. Initially, we're going to supply 0 for I and array.count minus 1 to j. Then we say false to the removed already. Now we run the loop once again, just like old one, like old, like previous variation of palindrome. I less than equal to j, we still run that. If these are equal, we increment it. Else, we check if we have removed the element already or if we have skipped over already. If that is true, we return immediately false. We say like, hey, we have already skipped over, but there's another element that we found like that. So we should not continue forward. So we return false. That means that palindrome is not valid by removing at most one element, one character from the string. Okay. If that is not the case, we check two things. We check if we can increase the index of I and still get to the end, right? Or if we in, if that's not true, then if we basically uh, do the same thing for j by decrementing j, and basically if that can make it through. If either one of these return true, that means we can skip one element and then get our result. So now going back, we had that b not equal to c encountered. Now if we put that in here, so if you increment I becomes 2, right? That means I is less than equal to 2. So we're gonna go into the loop. We're gonna say, are they equal? No. Already removed. We are setting it to true. That means we have already removed that. So we're just gonna return false here. Okay. So we return false here. This turns into false. Okay. Now we check our conditional solve. Okay, so we say is so this is not possible. Incrementing I is not possible, but decrementing j is possible. So let's see if we decrement j by 1. So we decrement I is pointing to 1, j is now pointing to 1 too, right? So this still is valid. Now both of these point to um, b, right? Both of these point to b. Now, in that case, we say now you can actually document and everything, and that's when the loop ends and we return true. Because by removing C, by skipping over C, we actually found our solution. Okay, so hope that actually made a difference, like, or that made sense, how we can actually compute this, another variation of valid palindrome. So let's take a look at this example in the code and execute some different, like, variations of it. Okay, so let's create a function, valid palindrome. We take a string and we return a bool. Okay, first we take our string and convert it into an array. Then we create our internal function, and this will take array, start pointer, and a pointer, and removed. Okay, and this is also going to return a bool. All right, so we're gonna simply return in the internal valid palindrome with our array, start pointer at 0, and pointer at array dot count -1, and false if it's not been removed. So it's not been removed yet. Okay. So now here we say var I is equal to start pointer, var j is equal to end pointer, and we say while I is less than equal to j. Okay. And we say if, right, array at I is equal to array at j, those two characters are same, then we simply increment I and we decrement j by 1 and we continue forward. If that's not the case, we first check if removed is equal true. If it is true, that means we have already removed an item, skipped over. So we're simply going to return false here. Okay. If that is not true, right, then we're simply gonna say we're gonna go loop into uh, gonna go like recurse again into the function, and we're gonna say take the array, take the start pointer as I, increment that by 1, and check if that is possible, right? So if we increment I by 1, if skipping over from the start would make this a valid palindrome. Now, if that's not true, then take uh, j minus 1 and sorry, I and j minus 1 with true as skipped over or removed already, and see if that actually makes any difference. Now, if any of these uh, basically uh, return like true, we continue forward and we reach to the end, and then we get our result back. Now let's take an input. So let input, and we're gonna take this ABC A first, and we're gonna print first input, valid palindrome. Input is input, and then we run this. Okay, so okay, uh, removed. Okay, we just need to. It's just a search thing. Okay, so ABCA is possible if you have if you remove C. Um, ABCAA is not possible because you have more than one element that you need to skip over. Now let's take a rather hard example. So ABCDO, okay, and DBA. Okay, so we take this example, and this is going to be true because we're going to skip over C. Okay, so in this case, you're going to notice that C is going to be skipped over, and I is going to be the one that's going to be incremented. Okay, so run it through various different scenarios, various different examples, and see if you can basically learn the pattern and see how it's actually working out. Okay, put a whole bunch of print statements and see. Okay, so the order time complexity for this one is, I would say, so looking at it like, you're gonna notice that it's actually gonna be more than O of n because like, we have this um, internal valid parameter like recursion going on. But I would still say it's O of n. Why? Because this value is going to be much, much smaller for this particular loop because we are not going to go over a whole bunch of times into it. So for that reason, we are only iterating like at a large scale. We're only iterating like over the loop once, and we are iterating only half of the loop because we are incrementing pointer from the start and decrementing pointer from the end. So that actually also um, kind of like contributes to the time complexity. So time complexity for this one is going to be O of n. Okay. Hope you guys enjoyed this video. Thanks again for watching, and I will see you guys in the next video. Thank you.